Games here. Let's review parts of a circle. First of all, this circle is named by the center. This is circle P. Next thing's a radius. A radius is a segment joining the center of the circle P with a point on the circle D. In this case, there are two other radii in this circle, segment PE and segment IP, but the one that is labeled is segment PD or segment DP. Doesn't matter the direction that you name it. Let's see. Chord joins 2 points on the circle. Segment KC or segment CK. The 2 points on the circle are point K and point C. Diameter is the entire blue. It is a special chord. It is connecting 2 points on the circle, I and E, but it goes through the center. So it must go through point P, which it does. Secant line is a line, notice the arrows, that intersects the circle in 2 points. Those 2 points are point J and point H. So this is line JH or line HJ. Doesn't matter. Tangent line is a line that intersects a circle in exactly 1 point, and that point is the point of tangency, which in this case is point E. An arc is part of the circle. This one is going from point A to point B on the circle, and that is an arc. It happens to be arc AB or arc BA, which is a minor arc. Maybe get to that later in your studies. This is a sector. It's part of the interior of the circle. It is cut off by 2 radii. So segment PG is a radius, segment PF is a radius, and then an arc, arc FG or arc GF, and that cuts off part of the interior of the circle. That is a sector. Circumference of circles and arc length. Circumference is the distance around the circle. We have 2 different formulas for it. 2 pi r, where r is the radius, or pi times d, where d is the diameter. So we have arc length as well, and that's just part of the circumference. So that is 2 pi r because it uses the radius. And then we want the fraction of the circle. So theta is the measure of that central angle that intercepts the arc. And we want that over 360 because 360 is all the way around, but we just want a fraction of it. There is our central angle theta, also in our formula. Fraction of the circumference, already said that. Let's go. Area of circles and sectors. So area of a circle is the space inside the circle, and the formula is A equals pi r squared, and r, of course, is still our radius. So we have the area of our circle, and we have an area of the sector. So just like the arc length, it is a fraction, but this time of the area. So they have the arc measure instead of the measure of the central angle. They are equal because of the central angle and its intercepted arc have the same measure. And it might be difficult to put it in that black space. So we have the fraction n over 360 times pi r squared. Arc measure, remember, is in degrees, and that's a fraction of the area.